Find the characteristic roots, that is eigenvalues and corresponding eigenvectors of this 3 by 3 matrix. Let us take this matrix as A. Let us take this matrix as A, that is 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. Now to get the eigen values, we find out characteristic equation. Characteristic equation CE of matrix A, of square matrix A, is A minus lambda I determinant equal to 0. This is the characteristic equation. Now in order to get this A minus lambda I matrix, we subtract minus lambda from this principal diagonal elements. So this will now become 6 minus lambda, 3 minus lambda, 3 minus lambda, and other elements will be same as minus 2 2. In first row, minus 2 minus 1 2 minus 1. Now we have to find out the determinant of this matrix. Now we want the determinant of this matrix, that must be equal to 0. Now in the first row, we assign signs to the first row, that is plus, minus, plus. Now expanding along the first row, let me write down that this will now become 6 minus lambda into, now apply AD minus BC. Now leave the first row and first column, then we have this 4 elements. Now apply AD minus BC here, cross multiplication, that is 3 minus lambda into 3 minus lambda, put minus sign, then we have minus 1 into minus 1. Now minus of minus will become plus 2 into, now leave the first row and second column. Leaving the first row and second column, we have this 4 elements. Now we have 2 into minus 2 into 3 minus lambda, put the minus sign, then we have 2 into minus 1. Next we have third element 3, that is 2. Now leave the first row and third column, then we have this 4 elements. Now apply AD minus BC here, minus 2 into minus 1, then we put the minus sign, and 2 into 3 minus lambda equal to 0. Now solve this. 6 minus lambda, 3 minus lambda into 3 minus lambda will be 3 minus lambda square, so this will become 9 minus 6 lambda plus lambda square. Here I have minus sign, minus will become plus. Now this will become minus 6. Now 2 into minus 2 into lambda will be plus 2 lambda plus 2 into, this will become 2 minus 6 plus 2 lambda equal to 0. Now this will become 6 minus lambda as it is, into here lambda square first, next 6 lambda, then 9 minus 1 will be 8 plus 2 into 2 lambda, next we have minus 4 plus 2 into 2 lambda, next we have minus 4 equal to 0. Now multiply this 6 to this term, this will become 6 lambda square 36 lambda into 48. Next we have multiply minus lambda, then we have minus lambda cube plus 6 lambda square minus 8 lambda plus 4 lambda 8 plus 4 lambda minus 8 is equals to 0. Now highest power is lambda cube, so write down lambda cube. Next we have lambda square, it will become 12 lambda square. Now lambda term, here minus 36 lambda minus 8 lambda. See here we have 4 lambda, here 4 lambda, 4 lambda will be 8 lambda, this 8 lambda, this minus 8 lambda will get cancelled, so here we have minus 36 lambda only. Then we have constant term here, 48 is there, next after 48 we have 8 8 16. Now we have constant here, that is 48, then we have minus 8 will be 16, (48) and minus 60. So we have 32 plus 32 equal to 0. Now take minus common, then we have lambda cube minus 12 lambda square plus 36 lambda minus 32 equal to 0. This is a cubic equation having 3 roots. Let us take one of its roots be 2. Let us verify whether 2 is a root of this cubic equation or not. Put lambda equal to 2. Here we have plus 36 into 2 minus 32. So 2 cube is 8, 2 square is 4, 4 into 12 will be 48 plus 72 minus 32. Now we have this 72 plus 8 will be 80, 48, 32 will be 80. So we have 80 minus 80, that will be 0. Hence we say that lambda equal to 2 is the root, is one of the root of characteristic equation CE. Other 2 roots can be obtained by synthetic division. The other 2 roots can be obtained by synthetic division. To do so, take the coefficient of cubic equation. Lambda cube coefficient is 1, lambda square coefficient is 12, lambda coefficient is 36, constant is minus 32. Here we have lambda equal to 2. Now put 0 below this one. Now add these two, it will get 1. So 1 into this lambda will be 1 into 2 will be 2. Now add this, we have minus 10. Minus 10 into 2 will be 20, minus 20. Here I will get 16. 16 into 2 will be 32. Now from this coefficient we will get quadratic equation, that is 1 lambda square minus 10 lambda plus 16 equal to 0. These are the coefficient of quadratic equation. Now for this quadratic equation, factorize this. Here I have lambda square 1 into 16. Factors will be 8 2s are 16. If we add, we'll get 10 here. So 8 lambda minus 2 lambda plus 16 is equals to 0. Take lambda common, we have lambda minus 8. Minus 2 common, we have lambda minus 8 equal to 0. Lambda minus 8 is common, then we are left with lambda minus 2. So that must be equal to 0. From this, lambda equal to 8, lambda equal to 2. We got all the eigenvalues, or we say characteristic roots or eigenvalues, that is 2, 2 and 8. Here 2 is repeated twice. Now we want the eigen vectors corresponding to this eigen values. Now for eigen vectors, we consider the system. We consider the system. Which system? A minus lambda I matrix into X is null matrix. So I want A minus lambda I here. That can be obtained from this. See here, we have this A minus lambda I inside this mod. Then I'll copy this here. So we want this elements A minus lambda I matrix into, we have x1, x2, x3, or we can take xyz also, variables, null matrix. Now let us take this as equation 1. Now I'll take eigen vector corresponding to eigen value lambda equal to 2. Here 2 is repeated twice. So for repeated eigenvalue, I am going to find out eigenvector. Now put this lambda equal to 2 in equation 1. Then what will happen? This equation 1 will now becomes, put this lambda equal to 2 here in place of lambda. So this 6 minus 2 will be 4, minus 2, 2, minus 2. Next 3 minus 2 will be 1, minus 1. Next we have 2 minus 1, 3 minus 2 will be 1. So we have this matrix x1, x2, x3 is equals to null matrix. Now carefully observe this matrix 4, 2, 2, 2, 1, 1, or this 2 minus 1, 1. We have first row R1, second row R2, third row R3. If we see carefully, then R2 is same as R3. Both are same, but signs are different. So minus of R3. These two are same. Similarly, I can see that R1 is twice of R3. Right? So all these rows have common factor. It means that we can get only one equation from this system of equation. So out of these three variables x1, x2, x3, we have to suppose two variables, since we will get only one equation. Other two are having multiple values, that is common factor multiplied to the base fundamental equation. So what we'll do, we modify this equation, or we try to make R2, R3 0 by echelon form. So my aim is to make these two elements these two elements 0 by using R1. So what operations that I am performing here is I am changing R2 to R2 minus, first of all write down R2 as R2 R1. Now multiply the coefficient of this. Okay, if I multiply 2 to R2, I'll get 4. So twice of 2 is 4, and these two are having different same sign or different sign. Plus 4 is there, minus 2 is there, so opposite sign is there. That's why I'm writing plus here. Now 2R2 means multiplying 2 here, it will become minus 4 to minus 2. R1 value, R1 is 4, minus 2, 2. Now if I add this, I'll get 0, 0, 0. So new row 2 have all elements 0. Now let us modify R3 as R3 with the help of R1. Now if I multiply 2 to R3, it will become 4. So what I am doing here, I am just multiplying 2 here. So this 2 into 2 will become 4, and 4 minus 4, this R1 row 1 4 and this row 3 4 will get cancelled. So what I am doing, I am writing 2 here, and since R1 and R3 have positive sign, element 1, this 4, see here, this 4 and this 2 are having same sign, so that's why I am writing minus here. Now 2R3 will be multiplying 2 to R3, that will become 4 minus 2, 2. R3, now we have R1 is 4 minus 2, 2. Here we have minus sign, so multiply minus, this will become minus plus minus. So we have 0, 0, 0. This is row 3. No new third row. So this system of equation will now become 4 minus 2, 2. Row 2 is 0, 0, 0. Row 3 is also 0, 0. So we got this matrix. Here we have x1, x2, x3 equal to null matrix 0, 0, 0. Now by backward substitution, here we have x1, x2, x3. So this will become 4x1 minus 2x2 plus 2x3 is equals to 0. Take 2 common, we have 2x1 minus x2 plus x3 is equals to 0. Now we have only one equation and 3 unknowns. We have one equation and 3 unknowns. Unknowns are x1, x2, x3. So one equation means other 2 unknowns can be assumed. Let us take the unknown x1 as some k1 and x2 as some k2, right? I can take x1 x2 or x2 x3 or x3 x1. So I am taking x1 x2 as constant. Now put this x1 x2 in this equation. So this equation 1 will now become 2 into x1 is k1 minus x2. x2 value we have k2 plus x3 is equals to 0. Now this x3 can be written as we have minus 2k1 plus k2. So I'll write down here x3 is equals to minus 2k1 plus k2. Now let us modify this x1 x2 value as what I'll do, I'll write down this as 1 k1 plus 0 k2. I want x1 in terms of k1 and k2, both should be there. Here I can write 0 k1, 1 k2. This is minus 2 k1 plus 1 k2. Right. Now let us write down the vector eigenvector capital X is equals to x1, x2, x3. Value, here we have x1 value, this will now become, x1 value is 1 k1 plus 0 k2, 0 k1 plus 1 k2, now minus 2 k1 plus 1 k2. Now we can split this matrix as 1 k1, 0 k1 minus 2 k1. This can be splitted as two matrices, 0 k2, 1 k2, 1 k2. So if I take k1 common from first matrix, we have 1 0 minus 2. Next we have k2 common, then we have 0 1 1. So these two are the eigenvectors. So hence I can write down here. Let me write down here 1 0 minus 2 and 0 1 1 are the eigenvectors corresponding to lambda equal to we have lambda equal to 2. That is, for repeated eigenvalue we have two eigenvectors. And see here, this x1 x2 x3 is a linear combination of two eigenvectors. So this is the answer for repeated roots. Now we find the eigenvector corresponding to lambda equal to 8. Now we find eigenvector corresponding to lambda equal to 8. Here we take lambda equal to 8. Now, so put lambda equal to 8 in this equation 1. Now the equation will now become, here put the value of lambda as 8 here in this equation 1. Here I'll get 8 in place of lambda. So this will become 6 minus 8 will be minus 2, minus 2, 2, minus 2. 3 minus 8 will be minus 5, minus 1. Next we have 2 minus 1. 3 minus 8 will be minus 5. Now here I have x1, x2, x3. Column vector or eigenvector I can say. Here I have null matrix. Now we have this system of equation. If I see here, this matrix equation has 3 rows, R1, R2 and R3. If I carefully observe R2 and R3, see here we have 2, 2, 5, 5, 1, 1. So I can see R2 and R3 have same elements, right? These two are having same elements. So these two will represent a single equation. So what I'll do, I'll eliminate one of the equation, or I can convert it into echelon form, row echelon form. What I'll do, I'll make these two elements 0 using minus 2. So the transformation that I am going to take is R2 is transformed to take R2 using R1. Now see here, see the elements, we have minus 2, correct? So direct substitution, direct subtraction will give us 0. So what will happen? Next, we want R3 transformation. R3 will change to R3 with the help of R1. See the first element of R1 and R2, both are 2 but with negative sign. So I'll put minus sign here. For different, we put plus sign. So I'll put plus sign. Then what will happen? It will become 0. Now this system of equation will now become minus 2, 2. Then R2 minus R1 is 2 minus 2 will be 0, minus 5 minus of minus 2 will be minus 3, minus 1 minus 2 will be minus 3. Next we have 2 minus, okay, this 2 plus 2 will become 0. Next we have minus 3. Now minus 5 plus 2 will be minus 3. Now again, if I see this matrix, I can see that second row and third row are same. Second row and third row are same. So what I'll do, I'll eliminate R3 by changing R3 minus R2 so that this element will become 0. So what will happen? This will now become minus 2, 2, 0, minus 3 will be same. This will become 0, 0, 0. Now by backward substitution, I can see that x1, x2, x3 will be there. So from this I'll get 2x1, converting the matrix into equation form, minus 2x1 minus 2x2 plus 2x3 equal to 0. This is the first equation. If I take common from this equation, then I have minus x1 minus x2 plus x3 equal to 0. Now second equation, this comes from first row. Row 1 will give us this equation. Now row 2 will give us 0x1 minus 3x2 minus 3x3 equal to 0. If I take minus 3 common, we have x2 plus x3 equal to 0. Now we have two equations and three unknowns. Two equation and three unknowns. It means that we have to select one of the unknown. So let me take x3 as some constant k. Right now, then x2 will become minus k. Next x1 will be from this equation. From this equation, x1 will become minus of x2 will minus k plus x1 plus k. So we have minus over 2k. This will become 2k. Now the eigenvector capital X is x1, x2, x3. So this will become x1 is 2k, k and k. Take k common, we have 2 minus 1, 1. If I take k value 1, then what will happen? This capital X will become 2 minus 1, 1 is the eigenvector corresponding to lambda equal to 8. Lambda equal to 8, we got this eigenvector.